And let us continue with Padmanava Sen from Barkhausen Institute, who will be talking to us about the Instinct project. So please, Padmanava, the floor is yours. We can already see your slides in full screen mode. Excellent. Thank you so much.
Thank you for the opportunity. My name is Padmanava. I'm from Barkhausen Institute, Dresden, Germany, and I'll be talking about Project Instinct. So, one second. Okay. So it's really surprising for me to see so many projects in joint communication and sensing. So that means this topic is really getting the due attention. And so our main goal is to do joint sensing and communication for future interactive, immersive, and intelligent connectivity beyond communication. And it will be a 36-month project, and the total EU funding is around 4 million. And we have total 13 partners. Just give me a second. I just put the point. Yeah, so we have 2 partners from Finland, Aalto and University of Oulu, and then we have 4 partners from Germany, BI, Barkhausen Institute, NEC, Bosch and Fraunhofer, and 4 from France, CS, UPS, Greener Wave, INRIA, and INSA, and 2 from Spain, I2CAT and Telefonica. UPRC from Athens will be our technical manager. Angelica Alexou is our technical manager, and all total, as you can see, so we have 4 industrial partner and 9 academia partner. The system concept, the way we vision the future of 6G is basically a combination of several different types of applications. Some of them will be sensing assisted communication. Some of them will be sensing enabled communication, where the communication systems need to be aware of the context. And also there will be a lot of focus on mobility, including vehicular communication, as well as probably in future drones. As well as we see that importance of reconfigurable intelligence sensors or holographic surfaces like holographic MIMO surfaces as well. So that's why we're trying to connect all of this, including distributed AI, and make a multifunctional 6G network intelligence, as you can see. And to go into our different objectives, first of all, we would like to bring an interactive sensing aided connectivity, where radars or other sensors are used to help the connectivity portion, and it has to be interactive. And second will be immersive and resilient sensing enabled connectivity, where basically it's communicate to sense, so that they work close to each other. And in this case we see a lot of roles that let's say reconfigurable surfaces, reflective intelligence surfaces, large intelligence surfaces, MIMO technologies will play. And third, which is the ultimate goal, is to have these two co-designed with the help of intelligence. It can be artificial intelligence, it can be also some surfaces that are intelligent. So the hardware as well as software intelligent. And with these 3 objectives, we come down to 3 pillars. So our first pillar is sense to communicate, as I mentioned already, and then communicate to sense. So sense to communicate will help improve, let's say, the radio spectrum usage, whereas the communicate to sense will create a context-aware platform, so that it's a more like a sensing as a service, as well as joint communication as a service, and sensing as a service can work together as joint communication and sensing as service. And the third is how we can offer brains to this co-design. So this way, the network intelligence will play a key role with the help of AI as well as intelligent materials. So with these 3 pillars, we would like to finally go beyond communication, as you can see. So first of all, we want to create enough innovation capacity and knowledge through these 3 pillars. At the same time, just innovations are not enough until it is applied for future applications, and that's why we see we have to play an active role towards sustainable 6G and standardization, and we have very good partners who are well integrated in 3GPP and 8C, and so through that we also want to impact towards standardization, and so that it can be adopted in future. And 3 scenarios, as we showed in our system concept, can be these 3. First of one, which is more close to mobility, where it's the localization, tracking, and also here the automotive vehicle, automotive application, and drones comes into picture. Second one is more in terms of the sense, communicate to sense. So we have to know the environment, we need to the context, and with this we can also make our next generation networks more efficient. And third is to know Internet of Senses, where we can augment different human sensing and tactile internets and all these other interfaces. With the advent of, let's say, XR, we need to integrate all of them into Internet of Senses. And how do we do that? Because this is a very ambitious goal. So first of all, we want to create a theoretical framework and system concept in the phase one. In the phase two, primarily we want to develop the ecosystem with waveform, algorithm, hardware, integration of the RIS and other technologies that we mentioned. And the phase three will be the demonstration and evaluation. So, and it is divided into 6 work packages. The first work package is primarily about the system concept and use cases and come up with the requirements. Second one is more related to the enablers, and this is the technical part. And third one will be more AI and machine learning empowered network. Fourth one will be the demonstrator connected to the phase three, and they will be supported by the project management and the dissemination work packages. To summarize, so our vision is I3, so interactive, immersive, intelligent, 6G connectivity beyond communication. Our pillars is says to communicate, communicate to sense, and a multifunction and integrated communication sensing, a joint communication sensing network. Our objectives is to do these three in an interactive, immersive, and smart way. And these are the actions we need to do that will be supported by our work packages. Finally, we'll come up with 3 hardware demo. They are like one straightaway joint communication sensing demo. Second one will be RIS as a sensor demo. And third one is the co-design part. We want to use SDRs for that. And we also have a software demo where we'll show the theoretical framework. Finally, we have to go into the key performance indicator and key value indicators, which will go from data rate to capacity, latency, connection density to, let's say, time to market, security, energy consumption, safety, trustworthiness, as well as resilience. So with that, so far what we have done, yes, with SNS we are continuously in connection, and we also have contributed to the annual report. In terms of EU collaboration, so some of us are also part of XIX2. So we already committed to an XIX2 joint workshop in October 2024. 60 census, we are also part of 60 census, and we will also started our discussions because UPRC is the technical manager. Also, they are part of IC6G, so we see a potential collaboration with IC6G, and we are of course open to more collaboration because since there is a convergence of the topics, we also see that together we can like make a really big impact. In terms of dissemination, we are there in World Mobile Congress and will be there in Joint Communication Sensing Symposium with tutorial, and also we have planned a demo, and then also we are part of Smart Antenna Workshop in Dresden in few days. To summarize, we had our kickoff. This is a picture from our kickoff. Some people couldn't join because of some strikes, but still we had very active discussions, and then we also took this picture during that. um, with that, I will conclude the discussion, and just thank you for listening. And I just want to acknowledge our BI team, our consortium partners, and Angelique, because she has been also contributed in the slides. So thank you.
Thank you very much, Padmanava, for the excellent presentation and for being even